Good day everyone, I am Mary J. Valencia and for today's video we are going to talk about mechanical wave. Before we dive in our topic, let's first identify what is wave. A wave is a disturbance that transfers energy from one place to another without transporting matter, while mechanical wave is a wave that only travels through matter. This means that mechanical wave can travel through solid like walls, liquid like water, and gas like air, but not in vacuum like space. Because mechanical waves rely on particles in order to transport its energy, and they cannot travel in the regions of space that void particles. There are two kinds of mechanical wave, the longitudinal wave and transverse wave. Longitudinal wave is a wave where the disturbance is parallel to the direction of the wave travels. In longitudinal waves, the particle's displacement is parallel to the direction of the wave propagation. The animation shows one directional longitudinal plane wave propagating down to a tube. The particles do not move down to the tube with the wave. They simply oscillate back and forth around the individual in the equilibrium position. Longitudinal wave has three parts: the compression, rarefaction, and wavelength. Compression would happen when the atoms are pressed close together, while the rarefaction is when the atoms are not pressed together, they are spread out. And lastly, the wavelength. The wavelength is the gap between the two rests or trough. Did you know that sound waves and seismic P waves are examples of longitudinal waves? Sound waves are longitudinal waves. They cause particles to vibrate parallel to the direction of the wave travels. The vibration can travel through solid, liquid, or gas. The speed of sound depends on the medium through which it is traveling. When traveling through air, the speed of sound is about 330 meters per second. Seismic P waves or seismic primary waves travels as elastic motion at the highest speed. They are longitudinal waves that can be transmitted by both solid and liquid materials in Earth's interior. With P waves, the particles of medium vibrates in a manner similar to sound waves. The transmitting media is alternately compressing or expanding. And the other types of mechanical waves is transverse waves. In transverse waves, the particles displaced is perpendicular to the direction of the wave propagation. The animation below shows one-dimensional transverse plane wave propagating from left to right. The particles do not move along with the wave. They simply oscillate up and down about their individual equilibrium position as the wave passes by. Transverse waves has four different parts: the crest, trough, amplitude, and wavelength. Crest is the top of the wave. Trough is at the bottom of the wave. Wavelength is the length of the wave, and amplitude of a wave is the highest amount of vibration that the medium gives from the rest position. And the rest position is the position where the wave would be if there was no movement. Did you know that the ripples on the surface of the water, vibration in guitar strings, and seismic S waves are examples of transverse waves? The circular ripples that produce on the surface of the water expand and propagates through water. As the ripples move horizontally across the surface of the water particles vibrates up and down. Thus, the water wave propagates horizontally. The particles of a medium vibrates perpendicular to the direction of the wave propagation. In guitar, if you pluck the strings, then we call it a disturbance of a medium. A simple kind of wave that called pulse is created. The pulse moves down the strings, and so everywhere the pulse goes, that portion of the strings acquires kinetic and elastic energy. S wave, also called shear or transverse wave, cause point of solid media to move back and forth perpendicular to the direction of the propagation. As the wave passes, the medium is sheared first in one direction and then another. Thank you very much for watching. I hope you learned something about mechanical waves for today's video. Bye!